Good morning, everyone. Thank you for joining us for the STEAMpower Conference. My name is Lina Ledesma Cortez, and I have the privilege of being your room facilitator this morning. I'm from the San Diego County Office of Education, and I'm happy to join everyone here this morning. I will be your facilitator, like I said. We ask that all attendees please keep themselves muted unless otherwise is asked during the presentation, but feel free to use the chat to ask any questions throughout the presentation. We will be answering those questions as we go through our presentation. And now I'd like to introduce to you Leslie Lowe's with Explore Mars, right along with NASA activities. Thank you for joining us. Thank you for honoring us with your presence today. Leslie, we're very happy to have you, and we're going to get started. Send it off to you.
Thank you. Thank you, Lina. And the honor goes both ways. I really do feel privileged to be able to be with you guys again this year, and very privileged to be able to help out you guys out there working with the kids to help them enrich themselves through the STEAM activities. So thank you for everything that you do for the kids. And I'm really delighted to be able to bring something exciting to them to help them get even more engaged in STEM and STEAM. I'm from the Jet Propulsion Laboratory. I'm in the basement of my house here near JPL up in Pasadena. And I would like to make sure that everybody there has filled out their poll, because I want to get a look at what your background is and understand who it is we're talking to. While you're taking one more minute to do that, I'd like to say that I'm going to try to make this interactive. So if you happen to have an 8x10 piece of paper, scissors, and a pencil handy, and I'm hoping that you can also simultaneously open a web browser, because I've got a couple of things I'm going to ask you guys to do as we're going through. If not, it's no big deal. But for those of you who have access, you can grab them now, and we'll be as interactive as we can in this Zoom format. Before we move on, I did want to point out to you, and I'm posting in the chat, that I have a blog through the Best of Out of School Time community there down in San Diego. And I invite you to check that out for other activities related to things going on in space exploration. That's why NASA is involved in this. Not only we care about the next generation, but we have a reason to celebrate things that are actually going on live in space exploration, and that makes us unique and something we really want to share with you. Okay, let's go on to the next slide, and let's see how our poll is doing. So Lina, if you can put up the results, let's get a look at how people are proportioned.
Okay, you want me to go ahead and end the polling?
Yes, please.
Yes, end the polling. I'm sorry, Annabelle.
Absolutely,
Yeah.
no problem.
Okay.
I'll go to share.
Okay, we've got an interesting mix. Wow, we kind of run the gamut between all the different grade levels, with a slight preference for 3 to 5, which is great. That's where we're going to target. And there will be something for the rest of you, and I'll make mention of that as we go through. In addition, these are multi-grade level activities that we're talking about. And I see in the spring and summer, we have a good number of people doing virtual programs. We have a couple people doing in-person programs, and then some doing a combo or both in what they're doing. Okay, that's good to know. Now, in terms of your experience in delivering STEM activities, some people have done it now and then. The majority have done it now and then, or have it a regular part of their program already. That's good. I see there's a few people who are just getting their feet wet, or have started to think about it. So that's really good to know too. So I'll try to address as much as I can any of those groups. And if you have a question during this, feel free to use the chat, and then we'll stop at different points throughout this and address your questions. Okay, wonderful. Thank you for sharing. And it's good to know who's out there. Terrific. All right. You can take the poll down now. Thank you very much. And we'll go on to the next slide.
Thank you there.
So can we advance the slide? There we go. Thank you. Thank you. Okay. So the natural question is, why Mars and why now? I mentioned that we like to tie them to different mission events. So I'll tell you why. We just had an amazing landing of the Mars 2020 mission on Mars itself. This is the latest NASA mission to touch down, which happened on February 18th. We left Earth back in July of last year. And the reason we went when we did is because the alignment of Earth and Mars being more or less on the same side of the sun would allow us to have the shortest time period to get. So that's why you'll see Martian launches every couple of years, because that's when the planets are aligned, literally the stars are aligned, so that we can, get to Mars in the most efficient and least amount of time. So we were trying to decide, of course, where to land. I mean, Mars is smaller than Earth. It's only about half the diameter, but it's like, where do you choose on that whole big planet to land? And we'll talk a little bit more in detail about that. But that's where the scientists were doing before they even, decided to launch the mission. They had to know where they were going to go. Then we had a contest to name the rover, and out of all the student submissions to name the rover, Perseverance was the one chosen. So it was really cool. Miller Schooler wrote the winning essay for that. Then, like I said, we launched in July. We've been on our way to Mars ever since then, and had that wonderful, exciting, successful landing on February 18th. Now the mission begins. We call it surface operations. And among the things, I'll tell you in a minute what the whole mission is about, but one of the things that we're going to do for a demonstration of new technology is to try to fly the first helicopter on another world. Pretty exciting. So on the next slide, you'll see that these are actual photographs during the landing of the parachute that opens to slow the rover package down while it's descending through the Mars atmosphere. And this was a big challenge that our very clever and well-kept secret engineers did a code on the parachute. So when you were looking up, you saw this pattern, and some smart people said, what does that pattern mean? And they actually figured it out. It means dare mighty things. It has to do with the letters, the number and the order of the alphabet that the letters occur. And there was a also number of the dark colored bands as it spirals out. Amazing. I didn't even think of that. It was a very well kept secret, so it was really fun when it came out. And then the other picture you see is downward looking under the sky crane apparatus, lowering the rover onto the surface. Pictures we have not seen before. They get better and better each time so that they can understand where they are and how things work, particularly in the case that something might go wrong. But luckily it did not. Let's go on to the next slide, where we are talking about the goals of the mission. So, why send these rovers to Mars? Well, this particular mission is a culmination of a bunch of others that we've had before. This one is really focused on the fact, like, did Mars ever sustain life? There's evidence that it had water flowing on it at one point. Now, when we say at one point, we mean, of several billion years ago. The planets are about 4.5 billion years old. And so we're talking long time ago, but there's been just compelling evidence that water has actually flowed and used to exist on Mars back in its early days. So we're going to look at different things about the Mars surface to try to help us understand if there was microbial life back then. And there's some wild speculation that maybe even our life came from other places before, it might have existed other places before it even came to Earth. So those are all the kind of really curious questions that we're trying to find out. Another cool thing that we're doing with this mission is to actually take samples and put them in special little containers. And the next mission will go get them and launch them back to Earth. So that's pretty exciting too. So how do we take all this cool stuff, next slide please, and go into after school? Well, what we have done this year is put up a special Mission to Mars Student Challenge. So we're going to be taking today a couple of activities from that challenge and showing you how to do them, and also let you know that it's part of a much bigger group of things that you could do in 7 weeks, because there are 7 weeks of themes running through the different stages of the mission, from, you know, learning about Mars, launching to Mars, landing, roving on Mars, all different kinds of things that you can do to understand the different stages of getting to Mars and exploring Mars. And they are designed for the K-12 and out of school environment. And I love doing it in after school because it gives a little bit of more freedom, of course, as we all know, to try things. You know, failure is okay. The idea is to learn from your failures, if you want to even call it a failure. I don't like it. What I like to say is that we learn from the outcome of the experiment. It may not be what we expected. That's okay. That's what happens with real space exploration too. That's why we do a lot of testing on the ground to try to see if we can make the corrections before we actually go to space, where we can't do too much about it. So we've got these 7 weeks of various age levels of activities that you can do as part of the Mars Student Challenge. And I will try to take a minute here and put this in the URL for you in the chat. 1 second, do this. It's probably gonna put too much in the chat, but here we go. Okay. Yeah, so you can register for this challenge at that URL there. And if you put down, the challenge registration will ask you what kind of program you're with, you know, whether it's museum, library, you know, family at home. If you put out of school time program, then occasionally we'll target you with special out of school time efforts. We have a training that I'll tell you about a little later that we've already done, that we did during the active challenge, which meant we started before the landing and we did a couple of weeks after the landing, but it's still all totally appropriate, even though it isn't timed with mission events at this point. Okay. The cool thing too is there are mechanisms to share the student work that you get out of this via social media. There's also interviews with specialists that are targeted at different age ranges. So, you know, you can show to the kids or have them look at it later, something they can show their parents that they're working on. It's very cool. End to end, all kinds of supporting things that you can get. Now let me go on to the next slide. The STEAM enrichment activities. The way I look at how we do things for after school is that you don't have to know the science behind it. We like to set it up so that you are the guide on the side. You don't have to be the sage on the stage. And So what we really need is for your enthusiasm to be able to do this. And I hope we set things up in a way that allows you to feel comfortable with doing these activities. We like to do things for different learning styles. They're, crafty, especially in the STEAM area. We like to get students up and out of their seats. We want you to want to learn something, and you'll be good at it if you just want to learn something. We hope that a lot of the things that we show you can use off the shelf materials. And then last but definitely first is attention to safety. We don't want to, we look at our activities to make sure that they're not something that could put anybody in harm's way, even a chance of it. Okay, what we're going to do, as I said before, during this is take some STEAM elements out of that wonderful package of activities and give you a chance to work on them today. Okay, next slide. What I wanted to show you here, as I mentioned earlier, that we've done all these past explorations of Mars, most of it pretty recently, although there was some done way back in the 70s by the US. But we have orbiters, so kind of like our GPS satellites or our cable TV satellites that are orbiting Earth, we've got some orbiters like that around Mars. And they have cameras on them, they have other instruments on them, and that's what really helps the scientists decide where to land on this great big planet out of all the choices, because we have those orbiters. And as you might know, we've had a good number of rovers and stationary landers on Mars as well. So what we're going to be looking at is, what do you see from orbit, and consider how that helps the rover. Okay, if we go on to the next slide. As I mentioned, we have pretty good evidence that water flowed on Mars in the past. And the picture on the left is an artist's visualization of what it might have looked like back then. You see the sky is more blue. There's actually clouds and maybe some flowing water. On the right-hand side is what that area looks like now. You see the channels that are carved into the surface left by that flowing water. And the fact that the atmosphere has changed over time. The atmosphere used to be maybe have more oxygen in it. Now it's mostly carbon dioxide. So trees might do okay in that environment, but not us. And we'll talk about that a little bit more. In the next slide, number 10, the biosignatures. So when I said we're looking for microbial life, we don't think there's little green men or anything like that, even though that was supposed early in the 20th century, that there might be actually living society there from seeing all those channels through telescopes. But that's not the case. And so what we're looking for is these special signatures that show you that only life could have created these. They're special shapes. There could be some minerals left behind that only life could leave behind. Things like that. They call it fingerprints of life. And so this is what we'll be looking for in these areas. Okay, next slide, and we're almost get to the activity. We have pictures of the 5 landing areas that the science team were considering as good places to look for these kind of signatures. And they had to decide how to narrow down. We couldn't have done it without our orbiting satellites being able to look down on the surface and take these wonderful pictures that you see here. So what they're doing when they're considering landing is it safe to land? You know, is it a nice smooth area? Are there rocks we need to avoid? So that's one big consideration, because the scientists may want to see areas that the engineers don't think they can get the rover into or land safely. Did it have liquid water? at one point. That's what we want to see, because that's where we think life might have evolved if it did. And do the rocks types that are in that area show signs of once being the right conditions for life? And are they also able to preserve those lights? Are they the right kind of rocks that will last and keep those signatures intact? And then thinking about future human exploration, are there water resources that can be used in the future? So that was what the scientists needed to do, is to pick all these different potential places and see which ones fit. And the winner is, as you'll see on the next slide, it's called Jezero Crater. And Jezero Crater was left by an impact a long time ago. We have a few of those on Earth, the craters on Earth, but when Mars was hit, it left this crater that scientists think filled up with water at one point. And so what we wanted to do was take a look at a special area of Jezero, where, as you see coming in from the left-hand side, their water flowed into the crater from surrounding areas. And so when that happens and water slows down, it can leave deposits, like Mississippi Delta is a great example. This is the Jezero Delta, and that is the area that was targeted. I'll point out to you that the colors that you see in the left-hand image are not true colors. They've been colorized by the scientists to indicate the height, the relative height of those areas. So you can see the blue is lower and deeper, which would make sense for a place where water could collect. Then you can see here that, I'm sorry, it's kind of small, but the star is the Octavia E. Butler landing site. It was named after her. And then if I blow it up again, those little boxes that you can see outlined in orange yellow are the actual photographs from our orbiters of where Perseverance landed, and all the pieces of it as it came together through the descending. So the parachute, it ejected the parachute. That's the one in the upper left. The crane that I told you about that lowered the surface, it flew off to another area, and that's the one right under the crater. Perseverance itself is by the carved line at the bottom. So it's pretty darn amazing that not only can we land there, but we can see where it was. So, all right, so let's get into the activity now. I'm going to take a minute and put the address for this activity with you. But this is where we really get into, I have to find the right window. Here we go. Okay. I put in the address for the series of activities that include Earth too, but how we're going to learn about what's on the surface of Mars through both science and art. I just totally love this activity, because scientists and artists really are alike, because both of them have to really observe. They have to pay attention to what they're seeing. They have to take it in so that they can really understand what it is they're looking at. So this activity not only gives you a chance to build that skill in your kids, because it gives them something to really focus on, but it appeals to lots of learning styles. It appeals to people that like to convey things through art. I've also found that people like me who have no art skill whatsoever can get into this activity too, because it gives you the chance to really look in to the activity and also understand what you're looking at. So you can be interpretive, or you can be literal in how you do these images. But either way, I bet you're going to learn something. I know that I do. Okay, so let's see. We need to I think I'll talk to you a little bit about the elements of art. Hopefully you've been able to go to that website, and I'll guide you through what we're going to do in just a minute. So the elements of art are used in this case, like I said, to really look at surfaces of planets. In this case, we're going to focus on Mars and try to understand what's going on. And it's really cool because some of the shapes or other characteristics of art map pretty darn nicely to what we can interpret about the surface. So I'm excited to share this with you. So the kinds of art that we're going to talk about are the line, so different lines, the shapes that you'll see, the colors of things that you'll see, the value. So that means how light or dark it is, basically. And the scientists call that albedo, but it's the same idea. And the texture. And of course, we can't touch it, but we can see how it might feel. We can interpret from the images if it's smooth, if it's bumpy, if it's chopped up, all different things. And we'll go through those. So on the next slide, if you could go through, and I've lost my slide window. Do we still have the slides up?
Yes, we'll give you 1 second, okay? 1 moment.
Okay. Just wanted to make sure on that. Because I think I'd like to leave them up so that you guys can refer to this slide. Wonderful. Thank you. Okay, so I'm going to talk through that. As I mentioned, we're talking about shapes, we're talking about lines, we're talking about color, the value, how light and dark it is, and the texture. And yeah, beautiful. Okay.
Wait, sorry, Leslie, to interrupt you. What slide were
You're on the right one.
On this one right here?
Go forward one. That's it.
Okay, okay,
Beautiful.
perfect.
So those different types of art elements work beautifully in interpreting what's going on the surface. So if you see a very circular shape from one of these images, chances are real good that it is from an impact crater. So long ago, and still happening today, actually, we'll get bombarded, and it happens everywhere. It happens on other planets. It happens on other moons, and it happens here on Earth occasionally, where something passes through our atmosphere and crashes into the surface, a meteorite. Some are bigger than others, and so they make bigger impacts. But by and large, if you see a circle shape, that's the result of it. On blobs, as we do, they tend to be irregular shapes, and a lot of times we see those in an image, it's a volcano or a lake. Okay. If you see straight lines, they might be tectonic activity. Like for those of us in California, we're familiar with tectonic activity, which is an earthquake fault. There can be other kinds of tectonic activity happening too. It's just the movement of the crust. Squiggly lines can be erosion, liquid wind. As I mentioned before, you can have true color or you can have added color. You have value versus light or dark, again called by the scientists albedo, and texture, the quality of the surface. What I'd like to do is get you guys started. I don't want to take a lot of time so that we can get through our other activities, but if you can click on that link and we can take a look at the activities, scroll down, since it's covering all elements of the art activity that you can come back and explore later. You can scroll down to section 4, step 4, where it has a quiz called Explore Mars with Art. I'm sorry, I forgot to ask you to go to the next slide there. And this is what it looks like. So I would like to give you guys a few minutes. Let's just say 3 minutes to take a crack at that and see what you think and see if you have questions. And while you're doing that, I'll stand by for other questions if you guys want to tell me if there's any questions in the chat.
Okay, Leslie, there are no questions at this time.
Okay,
So if we get any, I will signal so that you know that we have
okay,
some.
very good. While you guys are working on it, I'll yak a little bit. So there's 12 questions in here and they can take a bit of time, but the way it works is that, you know, you're given a choice of 2 answers, and a lot of them will be, you know, comparing shapes and also asking you which one you think is Mars or Earth. And sometimes that's pretty obvious and sometimes it's a little tricky. This is aimed more at the middle school level, this particular quiz. I'm excited to think about working on a K2 version where, since they work with shapes so much in those grades, that we can make it real simple and straight ahead and get them focusing on shapes that happen on the Earth and on Mars and other places throughout the solar system. Okay. How you guys doing? Anybody want to type what question they're on in the chat? I'll give it 1 more minute. You're probably busy working. Okay. So this is something, if you don't finish now, you can come back to and play around with. But it's something you can set the kids off too if you happen to have the computing power. I have a game where it's actually cards that you can pass out, and people do matching that way. But since you know, we've been in this COVID environment for a year now, we've come up with alternatives that can be done online if you're doing things virtually. Okay, I'm going to call time so we can keep going. Are there any questions on that?
No questions in the
No
chat at this moment.
questions.
No.
Okay. All right. Well, let's go on to the next slide then. And this would be, now that, you know, through this, hopefully you've been able to kind of get the idea that when you see different shapes or different colors or lines, that they tell you things about what you're looking at. And I love this one. This is actually the bonus question at the end, where of the quiz, where you put it all together. So we focused you in the quiz on small areas and individual features. This one puts a lot of them together. And I'll just walk through it so you'll have your bonus points when you get that far. This image, when we use color, obviously this isn't the true color, right? Because normally we don't see rainbow colors such as this. This is again colored for height. So the lower places are blue, the higher places are red, and even higher is brown. So it kind of gives you a map of what's a crater, right? If a crater made a hole, you can see that the on the right hand side, for example, you can see that the territory in which the craters occur, which is green, is higher, of course, than the crater pit that it made, which is indicated in blue off there to the side. You also might be able to tell that some of the wiggly lines in there might be a channel, evidence of a past flowing channel where liquid, it could have been water, it could have been lava, we don't know, flowed out of that or perhaps into that lower area there. And then the blobby shapes that are white brown on the left hand side are actual volcanic vents. So just from looking at that and understanding the correlation, you can make a big interpretation about what happened in this area on Mars. All right, so let's go on. I just wanted to mention that this is part of that Fuller activity. And what you would do after the kids have a chance to look through some of the images that you present, then you can get out the art materials and get them to create images. And I've done this workshop live a number of times, and even people that think they don't draw well come up with beautiful, beautiful things. And even if you just try to recreate what's there, it's just amazing. So you can pick images from with the quiz, or you can go online and research different Mars activities. You know, whatever the kids want to choose to draw, you can give them time to do it. And you can use anything from, I had my whole supply, though I'm not sure if it's going to show, you know, markers, plain old markers, colored pencils. If you want to really get fancy, you can go, I don't think you can see this. It is pastels that, you know, if you got a little bit of money to spend, you'd be able to do that. But you can use Crayolas. Stuff off the shelf is absolutely great. And then have the kids explain what their picture is about. You know, try to have them interpret it and what impressions, interpret it from both sides. What does this mean geologically? What does it mean to them as they interpret it and draw it? That makes a nice way to share. Okay, wonderful. Any questions at this point?
No questions in the chat, Leslie.
Okay, thanks. We'll keep on moving then. I told you that we wanted to talk about the helicopter in a little bit more depth. This is because I chose this one because it's happening very, very soon. So you would be able to actually see what's going on there at Mars. Thank you for advancing the slide. What we see here is an artist concept of this first Martian helicopter. You'll see it's really, really simple. It only weighs about 4 pounds. The blades from side to side are about 4 feet wide, and it's made of very, very lightweight material. And the only thing it has on it is a battery for power and a little motor to turn the blades and cameras that it'll take when it's flying, as well as on the top there are solar panels to charge it. So it's very simple, very lightweight, but it's the first time ever we're going to try something like this. And I happened to have the great pleasure once of going up where they were testing this at JPL, because, you know, the atmosphere at Mars is a lot different than Earth. And we'll talk about that a little bit more in another slide. But so you can't just, you know, get a drone off the shelf and stick it up on the lander and have it fly off, because it's not going to do very well. The atmosphere is so thin on Mars, it's 100 times thinner at the surface than Earth, that there has to be enough air to lift the helicopter. Helicopters work by the force of the spinning blades, causing air drag that gives it the lift, gives it this force upward because of the blades cutting through the air. So if you don't have as many molecules, you're going to have to spin a heck of a lot faster. And so these blades turn faster than on Earth too. And I'm trying to find 10 times. They turn 10 times faster. And at JPL, we have a chamber where they can take out some of the air and make the pressure like it is on the surface of Mars. And so that's where they did extensive testing and redesigning and different things about this helicopter. But like I said, the reason I wanted you guys to know about it is because it's going to be the 1st or 2nd week of April. We don't have firm dates yet when they start these flights, but it's coming up really, really soon. And so that if you've got something going on, you know, right now it would be fun to do an activity and then check out how the helicopter actually does. It's going to be doing a series of 5 flights, and they'll get increasingly aggressive, they call it. So at first they're just going to try to go up and down just to see if it can even lift off in that atmosphere. And then later they'll take a longer trip, and then aggressively longer and longer, but no flight's going to be more than 90 seconds long, because this is just to demonstrate the technology. The idea being that eventually, you know, helicopters could be part of exploration, kind of like drones, where you send them off to go look at things that you couldn't otherwise get to. So it's pretty darn cool. And one thing that's neat is the rover has a weather station on it, and the winds are pretty predictable on Mars, except for when dust storms happen. So, you know, they will be able to monitor the local weather before they decide to send up a helicopter. So pretty neat. So let me jump into the activity now. Next slide, we have the engineering design process that you can model with this activity. And so that's another skill that your kids can learn, is how do engineers actually decide, you know, on their final design? How do they know out of the world of possibilities what on Earth or on Mars they should check for the design that they use? So the first thing, of course, is you got to figure out the problem. And what's neat about this process is you can use this as a framework for guiding your kids. You don't have to have the answer as to what works. They're going to do the exploration. They're going to change the design. They're going to try different things. I would say in the activity about the helicopter, what I'd like to show you guys is, as the problem is, let's go for hang time. Let's see if we can keep the helicopter up as long as we can. And that's kind of comparable to what you would want to be able to do. Other ideas on what the problem could be, how heavy of a load do you want to be able to carry on the helicopter, and so forth. But let's go for hang time in this. And so I'm going to start you off. If you happen to have your paper and pencil, you could, I think it's the next slide here, you could trace this on your screen. But we, in the activity, give you a listing, and I'm trying to see, do I need to, yes, I do. I need to type this in. Let's see here. Okay, 10 minutes left. Got it. That has a template in that activity there. And I wanted to mention that a lot of these activities have different versions. They have a teacher-oriented version, and I mean inside the classroom. Doesn't mean it doesn't work for you, but they're a little bit more in depth. They also have a project-oriented one, so you can just guide the kids through doing this particular activity. So this template, of course, you only need one of the two. It's just made for paper size, and in real life, it's about 3 inches long by 9 inches across there. And we're going to have different parts of it. So what I'm going to do is try to make an attempt. I'm not sure it's going to work with the way this Zoom is set up. So I'm going to just talk through it a little bit. In the template there, what you would do, as it shows, is cut along all the dashed lines. The solid lines are where you're going to fold, and the dashed lines are where you are going to cut. And what the first thing you want to do, it goes in order, is to I'm trying to find my example here. Hopefully you can see this guy. You're going to cut along these two areas here once you've got the cutout, and these are going to be your rotors for your helicopter, right? And so then once you get them cut, you bend one way, it doesn't matter. You bend one the other way, and now you've got your rotors, okay? on the rest of the part here, I hope, yeah, this is going to work. Oh, come back. Darn. Sorry about that, guys. There it is. Okay, so you see the X, the Y, and the Z. We're going to take, oh, don't go away on me. We're going to take a Y and an X and fold it behind, and the Z goes up so that you can keep the X and Y. And this is your payload down here. This is what you're trying to stream. And you can print it on regular paper. You could try printing it on heavier paper, all different kinds of ways that you can try this thing. You can make it bigger or smaller. And that's the whole idea, is to experiment to see which one gets you that biggest hang time. And I think I can make this thing drop, and you can still see it. We tried this before. I'm going to hold it in front of my face and let go. And that's how it spins. I'm going to try one more time to see if it makes any sense. You can see that it spins and it keeps itself aloft. So that's what you're going to do once you put it together. Pretty simple. A lot of age groups can handle, I think, putting that design together and cutting it out themselves, but you can help if needed. And we'll be able to try to see, hold them at the same height, different models, which one stays up the longest. Okay, if we can go back one slide to the engineering design process. So we brainstorm solutions. The suggested solution is this particular shape, but you can brainstorm on how big it is, what you put it on, construction paper, regular paper. You can play around with how long the blades are, how long the body is. But the whole idea is to build that model or prototype, which you can start with the template and then test it and see which one. You can have different groups of kids or pairs of kids try what they decide on they want to do, and then have everybody compare their flight times to each other just by holding it up and seeing how long it stays up. So now, if you were going to follow through with what emulates the real engineering design process, and I know we're almost out of time, you would then say which one of these designs work the best and try to understand why. And then you might have another thing that you think could be even better, and keep trying and iterating that way, because that is the way it works in the real world. So that's why I don't like the word failure, because it's just an expectation that was different, an outcome that was different from what you expected. So, and the whole idea is to share it with others and compare and take the best out of that and learn from it. Okay, let's skip forward to the slide. Okay, yeah, let's go to the Mars atmosphere slide. And that's great. Thank you for being there. Here, what I wanted to emphasize to you is the difference between Mars and Earth's atmosphere, and the fact that that affects so much about how helicopters fly. It's much colder on Mars. As you can see here, the average range of temperatures across the whole Earth goes from minus 126 up to 136 on Earth, whereas Mars starts at minus 284 and goes all the way up to 86, believe it or not, occasionally, but it's not typical. It's usually quite a bit lower than that across the planet. So you're going to have something that has to be able to withstand those cold temperatures. Like I said, it's made out of different things. Earth is mostly nitrogen with some oxygen. Mars is 96% carbon dioxide, totally different ballgame. So it behaves differently, and it's much thinner, as I mentioned before. Okay, now since we're almost out of time, let's cover the last couple of slides. As I mentioned, if you want more training, I will also put this into the chat. Yes, I got it. This is a movie that we did as part of the original Mars Student Challenge. It talks about some other activities that we didn't highlight in here for you guys. So if you want to learn about how to land on Mars, you can model parachutes. And if you want to learn about launching, we have a straw rockets activity. And so you can learn that and more in this other training. On the next slide, we have the organization that we run here at JPL that you guys can join if you're interested. It's called the Museum and Informal Education Alliance. And it's an active community of practice that gives informal educators access to inside information on NASA. NASA, if you go, I'm sure you know, if you've ever looked for NASA stuff, there's an overwhelming number of things to get involved in. If you join this, we'll be able to help you find the things that you want. You'll have a forum to chat with other people. You will get weekly newsletters on things and be able to hear about things that are appropriate for the after school community. All right, and to close it out, I would like to go to the final slide and just remind you, I'm going to put the informal ed link into the chat for the My Alliance. Okay, and remind you that if you would like to go do any of these activities or any others that might interest you as part of the Mars Student Challenge, this is the website that you can visit to do that. And remember to register with affiliation of out of school time. And with that, I thank you very much for attending. And I'm hoping that you enjoyed this and that you will take this opportunity of some exciting things going on Mars to bring it to your kids.
Thank you very much, Leslie. Round of applause for you. It was amazing. I learned so much.
I'm glad.
Thank you to everybody for participating in this great session. We hope to see you around in one of the other amazing sessions that are lined up for us this week. If you have any questions, please reach out to Jessica Landris at the county office. Thank you, everybody. Thank you, Leslie. And please do not forget to fill out the evaluation for this session. The link, the Google link is in the chat. Thank you very much. Bye-bye.
Thank you.
Thank you, Leslie. Thank you, Annabelle.
Thank you for what you do for the kids.
Thanks, Leslie.
Thank you.